Okay, let's take a look at number 23. So we've seen something similar to this before, we just haven't really done it with friction. So we have a block of mass m, and then this one's got a mass 2m, and this one's got a mass of 3m. And we have an acceleration right here, and we're trying to find the coefficient of kinetic friction. So I think what we can assume is we can assume that the whole system is going to move to the right. So they're released from rest. Okay, that helps us. If we know they're released from rest, then we know they're not necessarily initially moving in one direction or the other direction. But since this one is bigger, we're going to assume it's all going to go over to this right in kind of this clockwise direction. And it says they accelerate, so we know it's going to accelerate. Otherwise, we could question whether it's actually going to move or not, but it says it's going to accelerate. So the very formal way of doing this is to draw a free body diagram for each of the blocks, and then write net force equations for each of the blocks, and then kind of solve them all simultaneously. So I'll set that up, but I won't solve it, and then we'll just kind of use our quick method of figuring things out. So here's block 1, FG1, and tension 1. Here's block 2, FG2, FN. I guess I'll write FN2. And then this is my tension 1. Here's my tension 2, which I guess is going to be this rope over here. And then I know that acting in the left direction, there's also going to be a friction force. So I'll just try to sneak that in if I can. It's kind of a little bit tight inside there. And then for block 3, we're going to have FG3, and we're going to have this T2. Then we're going to go and write net force equations for these. So we're going to choose this whole clockwise direction as positive. So this is up. So we're going to write T1 minus FG1 equals M1A, the first mass. This one's going to look like up and down direction I don't really care about. And then the side to side, well, actually I do care about the up and down direction because I want this force equal to this force. But the acceleration is happening in the side to side direction. So I'm going to have T2 minus T1 minus the force of friction is M2A. And then over for this one, I'll have gravity Fg3 minus T2 is M3A. And then we could solve this. There's 3 unknowns, T1, A, and T2, and we could solve it and then figure out the acceleration and do a lot of stuff and work backwards. And eventually we want to find this force of friction in order to find the coefficient of friction. So maybe we'll just take a little aside right here. How would we find the coefficient of friction? Coefficient of friction is going to be the friction force divided by the normal force. The normal force I know is just going to counteract the gravity right here. So this one right here is going to be the same as Fg2, which is M2G. And this friction force I would find out from this little area over here. I guess the other thing to note is that instead of writing M1A, I could also just substitute in capital M, and this one I could substitute in 2M, and this one I could substitute in as 3M. And then right here, I'm going to substitute in 2M for that one, since the mass of block 2 is 2M. And then we're hoping that all these big capital M's are going to cancel out. So rather than solving a bunch of simultaneous equations, I think maybe the easier way to do it is to kind of combine all the blocks together. So I'm going to make one big block, and its mass is going to be M plus 2M plus 3M. I should say we're going to need to go back to this diagram in a minute to figure out the force of the coefficient of friction, kind of this, which we got from here. And so we can't do that from doing this big block altogether. But we'll start here to figure out the acceleration. So in this direction, I've got this Fg3, which I'm going to label as 3mg. That's this block's weight over here. And in this way, I'm going to have 2 different forces acting. I'm going to have Fg1, which I can have as just mg, and then I'm going to have this force of friction right there. Right, now I can write a net force equation for this. F net equals ma. So this way is the positive direction. So I have 3mg minus these 2 things. Mg minus the force of friction equals, now this m right here is going to be 6ma. So I know I know A, and I know G, It's funny that the m's are still inside of here. So let's actually work backwards a little bit and try to get m inside of here somehow. So we can look back up here and see that the force of friction, well, maybe we can write it like this. The force of friction is mu times the normal force. And then looking back here, the normal force is going to be here. So now I can write the force of friction is mu times 2mg. Okay, so let's substitute, sorry, that was off camera. So I can say the friction force is mu times the normal force, and that's mu times 2mg. So let's stick that in for there, and let's see if we can cancel m's. So I get 3mg minus mg minus mu times 2mg equals 6ma, and great, all the m's are gonna cancel, and then I just have to solve this for mu, which isn't really too big of a deal. That's gonna give me 4g minus 2 mu g equals 6a. Then I could say that 2 mu g equals 4g minus 6a, and mu is going to equal 4g minus 6a all over 2g. And then those are just numbers that I can stick in. A was given in the problem, we know g, and obviously 4 and 2. So I'll leave you all to actually do the calculation if you want to, but this is the way we should solve it. All right, there you go.